Welcome to the session, Developing Addition and Subtraction Fact Fluency. In this session, we will look at the term fluency and what it really means, and then discuss strategies that we can use, especially in the K-2 classrooms, for developing fact fluency. Our expected outcomes for today are to define the term fluency, to examine strategies and tools for developing addition and subtraction fact fluency, and to engage in some strategies which will promote fact fluency. The first thing I wanted to start with was just looking at a simple fact. The fact is 8 plus 7. And I wanted you to just take a minute to think about some related facts or some mental math strategies that you could use to help solve this equation if you couldn't immediately retrieve the fact 8 plus 7. Hopefully you came up with one or more of these mental math strategies. You could make a 10 by saying, okay, if I move 2 over to 8, I can make that 10, and I still need to add 5. That makes 15. You could do doubles, take away 1. So I know 8 plus 8 is 16, and 1 less than that would be 15. Or you could do doubles plus 1. Well, I know 7 and 7 make 14, so 1 more than that would be equal to 15. There's a variety of strategies, and understanding a variety of strategies and how we can use these strategies to determine other facts, that's what fluency is. Before we get into the definition of fluency and what really makes a student fluent at their addition and subtraction facts, let's take a look at the requirements as they pertain to Common Core. This chart identifies the requirements from Common Core as it relates to fluency. I wanted you to have a chance to look at this to see the requirements related to your specific grade level before getting too far into the presentation, but we will be reviewing this chart again at a later time and discussing it more in detail further into the video. Fluent, according to Common Core, means fast and flexible and accurate. It might help to think of fluency as meaning the same thing as when somebody's fluent in a foreign language. When you're fluent, you flow. Fluent isn't halting, stumbling, or reversing oneself. It makes me think of the Bachelor, the former Bachelor that we recently saw on TV, Juan Pablo, and it makes me think of how he wasn't totally fluent in the language because he did stumble, he did reverse, and he had certain key words that he overly relied on while they might not have been most appropriate in the situation. So he didn't have that flexibility and that accuracy with the language. One example of this before we move on is just he frequently used the term it's okay, but he didn't always use it appropriately. He started to overuse it to the point that it became redundant and annoying, and it wasn't the best strategy or the best thing to say in that given situation. If he was fluent, he would use a variety of strategies or a variety of phrases differently depending on the situation. It's the exact same thing with addition and subtraction, knowing which strategy to use at what appropriate time. So let's talk a little bit more about fluency and how it connects to flexibility. Fluency and flexibility are closely related. Fluency is when you solve problems, you answer questions, and you extend patterns quickly and efficiently. Flexibility is the ability to solve problems in a variety of ways, apply current knowledge to solve unknown problems, or determining the most efficient method for solving a challenging problem. So they're very similar, fluency and flexibility. One example I wanted to give that is not focused on developing fluency is memorizing facts. A lot of times we'll try to get students to just memorize facts and we equate that with fluency, but this really isn't fluency. When you're asking students to memorize facts, they end up having 122 different or isolated facts within just numbers, adding numbers 10 up to 10 by 10 plus 10. They don't start to see connections if they're just memorizing facts. So students might not see that 9 plus 6 is related to 6 plus 9. And they also might not see that 9 plus 6 is related to 9 plus 5. They're not developing strategies to make them fluent in the language of mathematics. They're just memorizing isolated facts, like Juan Pablo memorized that term, it's okay, it's okay. If we can get students to use derived facts or related facts to solve problems, all of a sudden they have less work to do, and all of a sudden they have fewer facts to memorize. Some easy strategies to help with this are the double strategies, and then doubles plus 1 or minus 1. Like how we talked about adding 8 plus 7 is easy if we know 7 plus 7, or if we know 8 plus 8. Another strategy is seeing that 9 plus 6 is very similar or pretty much the same as 6 plus 9, because you would get the same sum. Also seeing the strategy of making 10. If you are adding two numbers and one is close to 10, you can go ahead and make a 10 and then add the leftovers. After you get those strategies covered, after you focus on the doubles, the commutative property, and then making 10, you only have 40 facts left to memorize. These facts all of a sudden become easy because they're things like adding 1 or adding 2 plus 1 or plus 2. The other thing is the compensation strategy can further reduce the number of these 40 facts left to memorize. For example, if I know that 6 plus 4 is 10, I can remember that if I do 6 plus 4, which is equal to 10, and take away 1, that I know the fact 6 plus 3. So thinking about what we know and how we can use what we know to figure out those unknown facts, that is what fluency is. Often when teachers are teaching fact fluency, they often equate that with drill. But the question is, does drill really lead to fluency? Research actually found that drill is extremely limited to developing fluency. Building meaning through those mental strategies or making connections between strategies, that's what's actually showing to increase fluency. Students that are using derived facts or those related facts, they're the ones that are able to retain that long-term knowledge more effectively, and they are the ones that are more flexible in their thinking than those students using just memorization and drill. But then you might be asking yourself, well, drill works. I've seen it work on some of my students. Why does it work? This bonding occurs, or this memorization occurs naturally in a small number of facts if they're repeated often enough. So students will naturally memorize some facts if they're repeated. Also, students with strong memories, they might retain all of the facts, and that would happen through any process. This is kind of like the ability to remember phone numbers or license plate numbers or trivia facts more effectively than other people. Many students are using derived facts when they're practicing drill. They just don't even realize they're doing it. So they're actually learning their own mental math strategies or those related facts to help them actually do that drill in practice without realizing. When asked what teachers typically do to teach fact fluency, besides saying drill, the second most common answer is the use of time tests. But time tests are actually a form of assessment, not an instructional tool. So thinking about time tests as instructional tools, that's inefficient. It can be damaging to student learning, especially those students who don't do well under time constraints, and it could lead to them not using efficient strategies and the students seeing that we're valuing the wrong thing, which is speed, versus those mental math strategies and that accuracy. Time tests are only suggested, or tests are only suggested after students have had a chance to develop mental strategies, to share and analyze strategies with peers, and practice the strategies in a variety of ways. In fact, one suggestion I would have is to take away that time constraint altogether, and as long as students are performing within a reasonable amount of time, using a variety of strategies or most efficient strategies, that is showing that they are fluent versus giving students that unnecessary time constraint. Well, let's go back to that chart that I showed at the very beginning of this presentation. I wanted to talk about it a little bit more now. You'll notice that at each grade level there is some sort of fluency required. The fluency within kindergarten and first grade, that is by using a variety of strategies. Those strategies might be still relying on a 10 frame, but students knowing when to use which strategy and using it efficiently, quickly, and getting that right answer within that reasonable amount of time. In second grade, you'll notice the little 1 next to the add and subtract within 20. There was a note below this chart that did say the students do have to have recall of addition facts through 20. That's sums within 20. That's that instant recall. But for adding and subtracting within 100, students can still rely on a variety of strategies, paper and pencil strategies or mental math strategies to do the addition through 100, as long as they're doing it effectively, efficiently, within a reasonable amount of time. At third grade, there's that note next to multiply and divide through 100. That is because students do need to have those facts, instant retrieval or quick retrieval of those facts with products through 100. At third grade level, the students need to be able to add and subtract within 1,000, and again, that's using a variety of paper and pencil strategies, mental math strategies, as long as students know the most appropriate strategy and can use it efficiently and within a reasonable amount of time. That's how they're fluent in it. And then it continues on in 4th through 6th grade. Again, that is within a reasonable amount of time using a variety of efficient strategies. Alright, now that we've talked about some basics related to fact fluency, let's go ahead and look at some strategies for developing fact fluency. Fact fluency actually begins in kindergarten, right at the beginning of kindergarten, with this term right here, subitize. Subitize just means instant recognition. There's 2 types of subitizing, and we will get into those in a little bit. The first type of subitizing is perceptual. That's where you might look at a die, the pips on a die, and instantly recognize there's 4 or there's 1. Or look at a domino and say, okay, there's 3 on this side, there's 3 on the other side. That's the instant recognition. We as adults, when we were younger, we got frequent practice subitizing through playing board games, by rolling die, by playing with dominoes. Our students today are very weak in this skill, and it's one of those things that if we just provide exposure to dice, exposure to 10 frames and dominoes, they will gain this skill. Perceptual subitizing just means looking at a common cluster of dots and identifying it immediately. Conceptual subitizing is a little bit different, where the brain has to do a little bit of more work here. Conceptual is where you might have a couple clusters of dots, and you need to figure out the total. For example, the domino towards the right has 4 and 4, so now I know, okay, 4 and 4, that's 8. This is leading more into that fact fluency, or looking at a variety of arrangement of dots and figuring out an effective strategy for finding the total. That's more conceptual, where you're having to think about it, versus perceptual is where you look and instantly know. A couple activities to develop fact fluency. The first one is dot card flash. If you're looking for these dot cards, they can be found at the website at the bottom of your page. So what you would do, and this would just be a 2 or 3 minute activity as a warm-up at the beginning of your class. What you could do is you can flash some dots to the students, have them tell you how many dots and how they know how many dots. For several weeks in kindergarten, or for several days in 1st grade, or even 2nd grade, you might start off with the arrangement of dots that are typical for the sides of the dice or on dominoes. So more of that perceptual subitizing. So just those frequent arrangements. And again, students would just say how many dots they see and how they know. Once you get further into the year, you might want to focus on that conceptual subitizing, where there's now multiple arrangements of dots, and the students have to share strategies for how they found out how many dots total. And again, this leads directly into that fact fluency. For kindergarten, again, facts through the sum of 5, and for 1st grade, facts through the sum of 10. Then you can get into more complex arrangements. And this would lead to some good conversation too, because some students might see this as 3, 3, and 1. Some students might see this as 2, 3, and 1. So all those different arrangements. Another activity for subitizing is sorting mini 10 frames that already have the dots on them. And again, the website for the dot card flash is the same website where you can find these mini 10 frames. So what you would do is you would give partners or tables a set of 10 frames or multiple sets of 10 frames, and you would say ready, set, go, and the whole class would see how fast they could sort the 10 frames. Probably what I would do is have maybe a sentence strip that had the numbers 1 through 10, and they could place the 10 frames right on those numbers. I would probably give the students maybe 30 or 40 10 frames to sort, just so they had multiple ones and multiple twos, because it's really going to lead into that instant recognition of quantity, or internalizing that number, that magnitude. Along with Subitizing, we need to focus on the concept of conservation. And conservation just means that no matter how the quantities are arranged, they still have the same amount or the same number. Students need opportunities to see quantities arranged in different configurations to develop this idea of conservation. Students, especially at the kindergarten level, and Common Core states this, need to have opportunities counting objects in a straight line, a clustered arrangement, or in a circular arrangement. At the kindergarten level, I would probably start with objects so that students, even if they're in a clustered arrangement, students can still physically move the objects to count. Then I would move into stickers or drawings where the students cannot physically move the objects and they have to figure out some method for tracking quantity as they're counting. One activity to promote conservation is dot card match, using those same dot cards that we mentioned a little bit earlier. This is kind of like that memory type of game where the dot cards would all be facing down and you would have to find 2 cards that match. And the dots might be in different arrangements. So I might flip over 2 cards and they both end up having the quantity of 6. And the students would quickly realize that although the dots are arranged differently, they could still have the same quantity on 2 cards. Using those same cards is another activity, dot card sort. For this activity, I would pull out that sentence strip that has my numbers 1 through 10 on it. And again, I would give groups or partners sets of dot cards, and I'd say ready, set, go, and have the different groups compete to see who could sort their dot cards the fastest. And that would lead to that instant recognition of number. Plus, it would lead to that conceptual Subitizing, where students are having to use strategies to count, but yet it also leads to conservation because different arrangement of dots would still have the same quantity. This repeated several times over many days will definitely lead to that idea of conservation. Another activity that I like to do is one of these things is not like the other. I would flash 4 cards on the board or projector or Elmo, and I would have students try to figure out which one of these things is not like the other, just like that old Sesame Street song. If you are looking for that old Sesame Street song, you can go to the link below. I found Cookie Monster singing one of these things is not like the other. And then students would have to, at the end, decide that this card right here has a different quantity and it is not like the others. So that idea, again, of conceptual Subitizing and some perceptual Subitizing with that last dot arrangement of 6, and then also that idea of conservation, or understanding that dots or things can be arranged differently while maintaining that same quantity. This focuses on the idea of conservation as well, giving students 6 popsicle sticks or straws or whatever, and seeing all the different configurations. And if this was first grade, I would even have the students write an equation, because remember, in kindergarten, students will not be assessed on writing equations. That begins in first grade. And then students could do a gallery walk after to see all of the different arrangements of sticks that have the same quantity of 6. The question at the bottom here asks, why is it a good idea to do that gallery walk after all the students make their arrangements? And that further leads to that idea of conservation, of all those different arrangements that still have that same quantity. One resource I wanted to point out is called Dot Card and 10 Frame Activities. This is from the Numeracy project from Winnipeg School Division. There are tons of dot card and 10 frame activities in here, tons of them, to lead to Subitizing, conservation, and even a lot directly related to fact fluency for first and second grade as well. Now that we've talked a little bit about some concepts, some important concepts related to fact fluency, I wanted to go into some tools and strategies that students could be using. I'll be explaining each of these in detail. One thing I wanted to point out is that there are different types of tools, and we need to make sure that we're always starting with the concrete and moving to the abstract. So as I show you some of these tools and some of these strategies today, I want you to think about, is it a concrete tool that I can physically manipulate, like combining sets of blocks to make one large set? Or is it more of a representational or pictorial tool where it's a drawing or an image on a piece of paper that I'm not necessarily physically manipulating? Or is it more of an abstract tool, which this would mean your mental math strategies? So the first tool I wanted to touch on, this is a really great tool for kindergarten and first grade, especially when it comes to those missing add-end problems that I know a lot of first grade teachers struggle with at the beginning of the year, but this is a really concrete way to do it. It's called use break-apart sticks. So let's take a look at a problem related to break-apart sticks. This problem says there were 10 birds in the sky, 4 were blue, and the rest were black. So how many birds were black? Well, let's see. So there were 10 birds in the sky. We'll use some counters to represent that, and obviously this is a concrete tool. We're going to break apart the 4 that we know. So we know 4 were blue. Now we need to figure out the rest that were black, and the remaining part from our break apart stick shows that there were 6 birds that were black. The important terms that you really have to develop in kindergarten and first grade are, especially as you use break-apart sticks or other strategies, are part, whole, understanding that relationship. So when you're solving problems, any type of word problem, you could talk about, well, do we know the whole amount? Do we know the parts? So what do we need to do to figure out either the missing part or the whole quantity? Every single time I talk about a word problem, especially in kindergarten and first grade and in second grade, I talk about the parts that we know or the whole amount that we know, and then what is missing. So let's talk about this again. Here's another example using break-apart sticks. It says there were 10 birds in the sky, some flew away, and there were 7 left. How many flew away? Okay, so do we know the whole amount of birds that were in the sky? Yes, we do, and that was 10. So now we can show that whole amount. Now some of them flew away. Do we know the part that flew away? No, we don't. Do we know the part that was left? Yes, we do, and that was 7. So we can break apart our 7, and we can see, okay, then that means there are 3 left. Another great strategy, and this one could be concrete if you're using objects, or it could be pictorial or representational if you're using drawings. This is a math mountain. This is a great strategy for math expressions if you're referring back to that textbook at all. The break-apart sticks is also from math expressions as well. So let's take a look at this same problem again. It says there were 10 birds in the sky, some flew away, and there were 7 left. How many flew away? So we remind students that solving problems, we need to think about the parts or the wholes, and we know the whole amount of 10, so we put the whole at the top. We don't know the amount that flew away, but we do know that 7 were left, so we will put 7 as one of the parts. And then we know that 3 is obviously the other part, so 3 is the amount that flew away. Let's take a look at another example of a math mountain. It says Maggie's mom baked some cookies. So we don't know the whole amount that she baked. Maggie ate part of the cookies and there were part left. So let's look at the parts we know. We know that Maggie ate 3 and there were 3 left. So now we can easily figure out the whole amount. Another way to look at that part-whole relationship is to use a number balance. This one came from ETA Cuisinart. I know they sell little student versions for just a couple dollars, or the class version, which is what you see here, that's a little bit bigger and more expensive. But this problem says there were 10 birds in the sky. 4 were blue, the rest were black. Same problem we solved before. We're trying to figure out how many were black. So we can put the whole amount on, or sorry, the parts on one side, the whole amount on the other side, and then we could just use some trial and error to find that missing part until we find out that 6 were black. One of my favorite places for mental math strategies is LearnZillion. Now, the LearnZillion videos do start at the 2nd grade level, but I've been telling 1st grade teachers it's a great place to find mental math strategies because there's a 2nd grade standard that talks about developing fact fluency through 20. If you can start pulling those strategies for students in first grade, that would be really helpful. So they talk about like making 10 or using a 10 frame or making 10 or using doubles. All those are really great strategies to use at the first grade level. I suggest you check out this website if you haven't already. One strategy that I typically focus on for developing addition and subtraction fact fluency at higher grades, maybe third grade for example, and with second later in the year as well, is to use bar models, which is more of a Singapore math type of method. Let's take a look at how this could look. The problem says Fred earned $97 at the rock quarry. The Great Gazoo gave him $49. So now we're trying to find out if Fred has enough money to buy a record player for $150. So we're giving them that visual, and they're trying to determine the sum of these two quantities and see if there's 150. Let's take another look at how we can use bar models. Barney is 52 inches tall. When he puts on his water buffalo lodge hat, he is 63 inches tall. So how many inches taller is Barney with his hat? So we're trying to figure out that difference. It takes students some practice to be able to effectively use these bar models, but I think this is a really good tool because it really helps students visualize the problem and see what they're trying to find out. Okay, so if you would like to pause the video at this point, this is your chance to practice using a bar model, and then just press play when you are done problem solving. Another great strategy is to use the number line, especially an open number line. An open number line just means that you drew it yourself and you might not be recording every number 1 through whatever, 1 through 10, 1 through 100. You're just only recording the numbers that are necessary to solving that problem. A great interactive tool that teachers can use related to the number line is on dreambox.com. If you go to dreambox.com/teacher-tools at the bottom of this screen, this is more of a second grade tool, maybe even a third grade tool. Research shows that John Vandewall, specifically from the book Teaching Students in Mathematics, has discussed that number lines are a really hard concept for kids to grasp, and the earliest the number lines can truly, really typically be grasped is at the second grade level. So using a strategy like this, the open number line, I would probably save that for second grade. I would focus on number lines for just basic counting tools at the first grade and maybe even kindergarten level, just to get them some exposure and get the students to understand that we're looking at the jumps versus counting the actual lines. If you would like, you can take a chance to, after going to dreambox.com, you can take a chance to try drawing your own number line to solve this problem right here. And then when you're ready, you can press play and continue the video. One more strategy, I talked about this one earlier, but I just wanted to point out this is another mental math or abstract tool. It's using doubles to add two numbers. This is, again, a second grade video, but looking at the quantities here and looking at the strategy, it's still a great strategy for first grade, and I would definitely probably show them this video as well. Well, we've talked a lot about all the different the theories behind developing fact fluency. We've talked about some strategies, some concrete, some representational, and some abstract. Now I wanted to give you a resource of a place you can go to find games and activities to really help students develop fact fluency. This is a book that every school in our county has. If you're looking for it, you can check either in the media center or your coach has a copy, your instructional coach has a copy. To make it easy for you, I've also put the link to the online version of the book on our screen right now. If you are looking specifically in this book for activities to develop fact fluency, at the very beginning of the book there is a section called Activities at a Glance. It gives you the names of all of the activities throughout the book. The activities for developing addition and subtraction fact fluency are all listed on pages 15 and 16, or XV and XVI. And then I'm going to just give you an idea of what those activities look like on the next few slides. So the book, if you go to the link on the previous slide or previous screenshot, the book will give you a list of activities, and they're all numbered. And when you flip to them, they look like this. What I love about this is they're really short, meaningful activities. You can do these as students are lining up for lunch. You can do these at the very beginning of math class just as a quick warm-up. The other thing I like about the activities is each activity is described in about 2 or 3 sentences, so they're really quick and easy for the teacher to read and implement. And most of them require very few materials. I'm just going to show you 2 activities just to give you an idea. The first activity is called 1, 2 more than dice. So the steps would be to make a die with the sides labeled 4, 5, 6, 7, 8, 9, and then to make a spinner labeled 1 more and 2 more. So then pretty much the students would just roll the die and then spin the spinner to determine the total. This is something that can be done really quick in just a couple minutes a day. Or this is something else that could be sent home for the students for additional practice. Here is another activity. This one is the students would make picture cards for each double fact and then include the matching fact or equation on the card. And then these could serve as flashcards or some frequent practice for the students. There are tons of activities like this in the book, Teaching Student-Centered Mathematics by John Vandewaal. And there's activities for every area of mathematics, not just addition and subtraction fluency. If you're looking for something for multiplication and division, they have those as well. Well, I appreciate you participating in today's session. I just wanted to give you a chance to reflect on how you will use this information from today. So if you have other teachers in the room to talk to, you can talk with them, or if you just want to take some time thinking on your own. And I hope you enjoy your day. Thank you.